I will be starting a new series on partial fractions. Partial fractions today. And we have a question that we're going to use to what? Explain partial fractions today. Pay attention. Resolve 2x plus 3 divided by into x plus 1 and into x plus 4. We should resolve it into partial fraction. What do we mean by partial fraction? This algebraic fraction on the board here is known as the what? The compound fraction of the algebraic fraction. And to resolve it into partial fraction simply means that we should decompose or split this algebraic fraction. We should decompose it into smaller fractions such that when I add the smaller fractions together, I will still get the main algebraic fraction. Those smaller fractions, those decomposed fractions, that's what we call partial fractions. And when you want to resolve into partial fraction or you want to decompose an algebraic fraction, the nature of the denominator of the fraction of the original fraction will determine the partial fractions. How do I know? Pay attention. If the denominator is a linear factor, if the denominator of the main fraction is a linear fraction, for example, x plus 1 and x plus 4, how do I know that x plus 1 and x plus 4 is a linear factor? Very simple. You will check the power of x. Here we have x plus 1. The power of x here is what? 1. This means that this is a what? Linear factor. Do you understand? Yes, exactly. So now that I have known that this denominator here, the two denominators are both linear factors, I can express this main algebraic fraction as, so it becomes 2x divided by 3, x plus 1, x plus 4. So how many linear factors do I have here? I have 2. It means that the partial fractions will be 2. So I can express it as a divided by the first linear factor plus b divided by the second linear factor. So whenever the denominator is a linear factor, this is how you decompose it into partial fraction. If there are 3 linear factors here, we will have 3 partial fractions here. So the number of partial fraction, linear factors in the denominator of the fraction will determine how many partial fractions we have while solving. All right. So it means that now before I can proceed, there's something I need to do here. I'm going to find the LCM of the what? Of the denominator of the compound fraction. Then when you find the LCM, then you multiply all through by the what? LCM. So if I multiply 2x plus 3 divided by this, the LCM is x plus 1, x plus 4. So this will become 2x plus 3. Of course, the LCM will cancel out the denominator. So if I multiply the LCM by this, x plus 1 will cancel out x plus 1. So I'll be left with x plus a into x plus 4, right? If I multiply b by this LCM, x plus 4 will cancel out x plus 4. So I'll be left with what? b into x plus 1. Of course, this fraction, the numerator and the numerator here are equivalent, all right? So there are 2 ways that you can solve this problem. When you want to solve problem on partial fraction, you can use the cover-up method. What did I say? Cover-up method. And you can use comparing the coefficient method. But I'll be using the cover-up method in this case. Now, what I'm going to do is I'm going to find A. So if I am to find A, what am I going to do? I'm going to eliminate B. And for me to eliminate B, what value of x can I put here such that everything here will be 0? I will just say x plus 1 is 0. That means x is equal to what? Negative 1. So to find A, I'll put x equals negative 1 so that B will be eliminated. So this becomes 2 into minus 1 plus 3 is equals to A into minus 1 plus 4. Then everything here becomes 0. So I have 2 times minus 1 minus 2. Minus 2 plus 3, I'll get 1 is equals to, then minus 1 plus 4, I'll get 3. 3 times A, I'll get what? 3A. So this means that A is equals to 1 divided by 3. So I've gotten the value for A, right? So I'm also going to get the value for B. So I'll say to find B. So that means I have to eliminate A. And for me to eliminate A, what value of F can I put here that will make everything become 0? I'll say X plus 4 is equal to what? 0. That means X is equal to what? Negative 4. So I'm going to put X is equal to what? Negative 4. Are you paying attention? Okay, so I'm going to come back here again. I have 2x, 2 rather, 2 into x is negative 4 plus 3 is equals to, so if I put negative 4 here, this will become 0. So eliminating A. So I have B into negative 4 plus 1. So let's solve 2 times negative 4, that is minus 8. Minus 8 plus 3, that is minus 5 is equals to minus 4 plus 1, you get minus 3 times B, you get minus 3B. So minus we cancel out minus, therefore B is equals to 5 divided by 3. Now, we have gotten the value of A, I have gotten the value of B. So what will now be the partial fraction? I will substitute A as 1 over 3, and I'll substitute B as well, 5 over 3. So A is 1 over 3, and B is 5 over 3. Right, so the partial fraction becomes 2x plus 3 divided by x plus 1, x plus 4 is equals to. So instead of writing A, I'll change it to what? 1 divided by 3 over x plus 1 plus B is 5 divided by 3 over what? X plus 4. All right, I can rewrite it as 1 over this 3 will be down here into x plus 1 plus then 5 will be up here divided by 3 into what? X plus 4. So these two fractions here is what we call partial fractions. Partial what? Fractions. Such that when you add it together, you still get this fraction. Yeah. All right, don't forget to like and share this video. Invite your friends. I will be doing more of partial fractions this week. Thank you. God bless.